Hi, this is Jim Wright, and this is the first of a series of lessons on how to use Post Builder to create post processors for your shop. This lesson is all about what is a post processor. I'm your presenter, Jim Wright. I've been in the CAM industry for quite a while. I've had the opportunity and the pleasure of doing a lot of varied types of NC programming. I also spent some time as an instructor teaching both NX CAM and NX modeling and also our Post Builder product. And if you're interested, you can follow me on Twitter at JimWright2. So I thought we'd take a look at what the NC language is before we delve into how to build a post processor. Other names for this are the G-code language or NC code, and typically it involves creating code that drives a computerized numerical control or CNC machining center. The language design for G-code language or NC language is very cryptic. It was designed that way because the original machine tools didn't have a lot of computer memory. And typically it's a word address followed by a number. And here's a typical line of code that you might see in NC code language. We start off with a sequence number, which is nothing more than a line number or an identifier so that if someone wants to search in the program for that line, he can do that. Next up is the G-code group for intrametric mode. In this case, it's G71 for metric mode. You can generally have multiple G-codes on the same line as long as they're not part of the same group. This second G-code is from the absolute mode group, which means I'm either going to be running an absolute or from a 000 program position, or incremental mode, which means I'm going to be moving this distance from my previous position. The last G-code we have is G00, which means move it rapid. So the machine tool will move as fast as it possibly can to this next position, and the next position is these Cartesian coordinates. Finally, we're going to turn on the spindle speed clockwise, and the spindle speed will be 1500 RPMs. So as we look at the NC language, we can see that words are grouped together, and really only one word from that group can be active at any time. For example, it's impossible for the machine to be moving at feed rate mode and rapid at the same time, so they are part of the same group. And also in that group is clockwise motion and counterclockwise motion. Another special thing about the NC language is words are either modal or non-modal. A modal word means the value stays in effect until it is changed or replaced by another word of the same address. For example, if I am at X position 1.2, that value is modal. I will stay at X position 1.2 until I get a new X word and a new X position. Some words are non-modal, and they're only active one time. An example of a non-modal word would be a tool change. I'm going to fire off a tool change, and then once I'm done, I'm not going to fire off another tool change. Macro calls are also an example of non-modal words. So a little bit of a history lesson. NC language was developed in the 1950s and 60s, and it had a standardized format for language and output so that all machine tools at that time had the same language. You could take a tape punch for one machine and move it to another and run it, as long as it had the same characteristics and kinematics. In other words, as long as they were both 3-axis machining centers. Initially these were hand coded, so somebody would sit down at a special typewriter called a flexowriter and then type out the words one by one, G00, G90, G71. And then it was typically delivered to the machine via a paper tape punch. In fact, if you'll notice on our NC code today, our extension for the files that we send to the machine for Siemens is called PTP, short for paper tape punch. However, today standardization has collapsed. There are very few G codes that will pass from one machine to another, and there's so much other code that is changed that you really couldn't take an NC program from one machine and move it to another. On the left-hand side, we have NC code for a Siemens control. In the middle, we have NC code for a Fanuc 6M control. And on the far right-hand side, we have NC code for a Heidenhain control. So control manufacturers have responded to customers' needs in different ways, and as a result of that, we don't have the standardization that we once had. Computer-assisted manufacturing came along in the 1970s and 1980s, and it is now very commonplace. The advantage to computer-assisted manufacturing is it makes it much faster to make an NC program. It eliminates a lot of the errors that we had, typing errors and things like that we had with hand coding. It allows for far more complex NC programs in a much shorter time frame than what we could ever do with hand coding. However, you must understand that the graphics that you see on the CAM screen is not the NC output. The NC output is the NC language, or the G-code language. So in terms of CAM systems, a post-processor is a translator to take that binary data from the CAM system and turn it into NC code for that particular machine. Without the post-processor, meaningful communication to the machine tool is not possible. So a post-processor definition is a software program designed to translate CAM data into G-code language for a specific machine. And as I mentioned before, for meaningful communication with a machine tool, all CAM systems need post-processors. There are two basic methods for converting this binary CAM data into NC code. There's a one-step method and a two-step method. Step number one, or option number one, is the one-step method. The post-processor is delivered with the CAM system, and it creates the code directly for that specific machine or control. The second method is a two-step process, and what happens here is generally a third party, not the CAM system vendor, will actually create the post-processor. So what happens in this case is the CAM system simply creates a generic cutter location source file, or CLSF, and then that CLSF is converted by post-processor into NC code for that machine or control. Now I think method one is better, and the reason I think that is because as we get into our PostBuilder product and as we start showing you how to create post-processors with it, you'll see that we can actually grab data and information that's not available in any CL source file. So speaking about post-processors and their availability, sometimes I hear comments like this. A post-processor is like a printer driver. I get a printer driver for free. Why isn't my post-processor for free? This other CAM company has a DVD with 1,000 post-processors on it. I know you've already made a post-processor for a machine like mine. Why can't I have that one? And the answer is, it's not that simple. Let's take the first comment. A post-processor is like a printer driver. The answer is not really. Printer manufacturers sell thousands of the same printer model. Machine tools have options, and everybody wants their post-processor to be able to use or not use that option depending on whether they have it or not. Very rarely are two machine tools exactly alike. Even if they're the same physical model, they might have a different controller, or they might have different controller software versions, or they might have a different option. So why do I have to pay for a post-processor? It should be included with the CAM system. Well, we include a lot of post-processors with our CAM system. And with PostBuilder, you can build your own post-processor for free. PostBuilder comes with a large library of machine tool types and controller support, and as we get into the actual lessons about PostBuilder, you'll see that much of what you're doing when creating a post is a drag and drop operation. It's very simple, very easy to use. The other CAM company has a DVD with 1,000 posts for free. Well, there's an old saying about free. You get what you pay for. And there's another saying about computers, garbage in, garbage out. If this post processor, which is free, doesn't match the requirements of your shop, is it really a bargain? What if it doesn't output the actual code that you need and you end up doing a lot of after post processor editing, or what we call fat fingering? Is that free? I know you've already made a post processor for a machine like mine. Why can't I have that one? Well, as we already mentioned, CNC machines are rarely identical. Even if they are, your shop does things differently, especially in NXCAM and CAM Express, which is highly customizable. Your shop may have adopted different practices that will not make this other post processor work for your shop, so it needs to be modified or customized. Let's play a little numbers game. Let's say that there's 20 major machine tool manufacturers worldwide. There's actually more than that, but we'll say 20 just to make it a nice round number. And let's say that each year, each of those manufacturers develops and sells 5 different models. Now, some of these are revisions from previous year's models, and some manufacturers sell more, some manufacturers sell less. But let's say on average that of those 20, that there's 5 different models that they make. Furthermore, let's say that each of those 5 machine tools models that they sell has 8 programmable options. So maybe it's a parts catcher or a tailstock, maybe it's high-speed spindle, maybe it's a vibration detection. There's all kinds of different options that machine tool manufacturers sell, and they have value. So let's say that there's 8 of those. And now let's say that the average lifespan of a machine tool is 20 years. Some last longer, some don't last as long. Well, we'll say that the average is 20 years. Finally, we know that there are different machine control manufacturers out there. Siemens is one, and there are others as well. So let's say that there's 3 major control manufacturers. Now, if you're quick at math, you already know the answer here. That's 48,000 post processors required. That DVD with 1,000 posts on it doesn't sound so good right now. But wait, there's more. Of those 48,000 post processors required, we've already mentioned that your shop has unique requirements and unique ways of doing business that no other shop has. I've worked in the post processor business for quite some time, and I've never been able to take a post that worked perfectly well in one shop, deliver it to another shop, and have it work perfectly well there. They always want changes or modifications. Every shop is unique, and one of the ways you express that uniqueness is through the code that you use at the machine tool. Hoover's estimates that there's 20,000 machine shops in the United States. 48,000 times 20,000, 960 million post processors. So when somebody says they have an off-the-shelf post processor for every machine, I'm not so sure that's actually true. So to summarize, the G-code language is what drives the CNC machine tools. And a post processor is the translator that turns that binary CAM data into the G-code language. Every CNC machine is different, every machine shop is different, therefore every post processor must be different. And typically speaking, an off-the-shelf post processor is not going to match your company's best practices for CAM system or shop usage. That's it for this lesson. In the next lesson, we'll actually open up Post Builder and we'll step you through the basic steps of creating a post and starting to test it using NXCAM or CAM Express. Thanks for viewing.